Hey guys, this is Rob. In this REVIT electrical video, we're going to do a deep dive into a more advanced topic, and that is family creation. We're going to create from scratch an EV dual circuit charging point. So where we start is new family, and we want to use an electrical fixture, not electrical equipment. Equipment would be panels, switchboards. We're going to use an electrical fixture. We don't want it ceiling-based or wall-based. This is just standalone. So electrical fixture, we're going to start with this template that comes from Autodesk in your Revit installation. So click on that, and let's open that up, and we'll see what it has. Now, if you're new to family creation, this is all, of course, new to you, and I'll try to step through the steps that I go through to create families. There's a lot of pitfalls you can fall into if you put too many constraints on things, if you don't use reference lines and reference planes properly. There's a number of details that matter. So I will try to explain what I'm doing here. There's a lot of great videos on YouTube and even on LinkedIn, places like that, about family creation that you can get more information. I wanted to specifically show how we create families here, and specifically for this charger, actually a charge point. So we have a number of levels already created, reference levels. And for example, this is the floor reference level. Here is the first reference plane, and a reference plane, if you know what a plane is, it's like a flat surface that extends to infinity in all directions. Now, the actual line shown here has a beginning and end, but in theory, that plane extends forever. This one is built in. It's called the center for front and back. We are really looking at a top view, top down. So this is the center. Front ends up being, I believe it's down, and back ends up being up. And then we also have one here for center, left, and right. And of course, those are more easily defined. So we have two reference planes that are built in, and the intersection of these two ends up being the insertion point. It can be moved around later if we need to, but right now that is the insertion point. So we're going to go with that for now. There's also a ceiling reference level, which looks similar. You have a 3D view, which there's nothing to see yet. And then you have elevations, a back elevation, front elevation, left and right. And those don't make much sense yet because we don't have anything drawn. So I start with the floor plan, the reference level. We're going to want our charger to extend from the floor. So let me show you what we're going to be actually modeling. What we have is Leviton's Evergreen 4000 level 2 charging station. And this one happens to be a dual port, as you can see in this picture. And if you look through the brochure, you can see what it looks like. It's kind of a bollard, tall bollard behind it, which is kind of a wireway. And then the front portion has the electronics and the charging mounting. And these are freestanding. They also make wall mounts. We're going to do the freestanding version. And this one shows some dimensions. Now, I've dimensioned in red some of the pieces I care about. It's the same height as the bollard. So I'm going to model and this is a rough model, not crazy geometry. I don't want this to slow down the performance of my actual model. So I'm just going to do the bare bones so that in some kind of a rendering or a 3D view, you would get an idea of what this thing is. We're going to model the wireway in the back, and we're going to model the wireway in the front. So what I've also done is looked at the concrete mounting kit instructions, and I pulled a page from that. As you can see, this is an outline of the unit. This is the front, and let me turn this around. We're going to model this with the front down, which is what REVIT wants to do. So this is the large front extrusion, and then the smaller footprint but taller cord manager footprint is up here. And as you can see, it actually has a lot of texture on it. From that picture, you can see that it's got some grooved faces here like this. We don't need to model all of that geometry by any means. So we're going to get the basic points. We're going to get an extrusion of this and an extrusion of that, and we'll also add a couple of these cord attachments here. So that's what we're going to make. So we'll get back to our REVIT family editor. I'm going to bring in this PDF of that base that I can use to trace around. So if I go to Insert up top, and I'm going to bring in a PDF, the import image will not be visible in projects, and that's okay. This is just for reference. So here it wants to import it at a certain resolution and all that. That's okay. We're going to scale this anyway, and I can put it anywhere. Now again, I want to rotate this so that the front is down. So let me rotate this right to left, and I rotated that with the rotate tool. And then I want my insertion point to be at the front, but first let me get this scaled properly. So they have a scale on this PDF in inches and centimeters. We want this to be actual size. If I were to annotate and draw a line from 0 out to what should be 8 inches, we will see that the actual line is 10 feet 3 1/4 inches. So we need to scale this down considerably. Well, to do the math, 10 feet 3 1/4 inches is actually 120 inches plus 3 1/4, so 123.25 is the total length, divided by 8 inches. It's 15.4. Now I can invert that. And we need to scale it by 0.065. So we need to scale this PDF by 0.065. So let me select it and go up to my Scale tool, which is under Modify, Scale. And we want to do a numerical scale. And we want 0.065. And then down at the bottom left it says click to enter origin. Well, we can scale it from anywhere. I'll just scale it from here. So there. And here's our long 10-foot line. We can get rid of that. So now we've scaled this down, and let's double check our dimensions. Go to annotate, symbolic line from 0, and see that 8 inches. So now we have this actual size. Now let's move this so that the front center of this charging station is actually at the insertion point. So I like to use the move tool and get as close as I can. You can see this pixelates as I zoom in. Right there, and then I'm going to make that point, this actual point here, and now we are as centered as we can get. Okay, so now we have that PDF set up to start drawing over. Now we want to create extrusions, which are a shape that gets stretched, like the good old Play-Doh maker, or making spaghetti, stretched to a certain height from this ground reference plane. To do that, we need to create some reference lines that we will use to establish the extents of our extrusion. We don't just start extruding, we need to draw reference lines first. It's always a good practice to create what you might call a skeleton that gets dimensioned and oriented and all that, and then apply your extrusions to that. So we're going to be using a lot of arcs to approximate these curves. So let us start right now by creating, on the Create menu, here we have our datum, which are reference lines and reference planes. Now reference planes are flat surfaces. There's no curve to it. So we want to use a reference line. As you can see here, it creates a reference line that you can use when creating a new family or create constraints. When you hit reference line, you'll see you have a number of tools available to draw different shapes. We can draw arcs. Now I like the start end radius style of drawing an arc. You can also use a center and ends. You can do some tangent if you need that, but I'm going to start with the start end radius arc. And I'm going to start at the center, because what I'm going to do is I'm going to draw half of this and then I'm going to mirror it so that it's exactly symmetrical. So let me start with my first point of my arc right here. My second point, let's see, this curves roughly like this, so I'm going to make the second point this corner. And then you can see my kind of a green and blue construction lines for this arc. Let me approximate this curve. Because we have this jog here, I'm going to just approximate the entire curve right there. I have thin lines on, but if I turn thin lines off, it's too thick to see. So I'm going to keep the thin lines on. That's that piece. Now let's do another one. Create, reference line, arc. Start here where it left off. Where's the curve? It kind of curves to here and then it straightens out. So I'm going to pick this line. And then I'm going to pick my radius to get approximately that size. Now it remembers where I left off, so I can just keep going. Let's pick another one. Roughly, this curves that way. So roughly here. Again, we're just getting an approximate. That snaps there. And this one, we will go to about that point and give it a curve like that. And then from here, I'm just doing this lower piece here. I'm going to go to the center again and approximate this curve. Click there and escape out. Now it's hard to see because of the PDF, but we actually have a green construction, well, green reference lines approximating this shape. Now I can take these pieces right there and I can mirror them about this center line. So up top to my tool, modify, here's a mirror and pick an axis, or you can mirror and draw your own axis. We already have an axis, that center point, center line. So mirror, pick axis, pick this line, reference line as an axis, and it mirrored exactly what I had before. So these are the construction lines, reference lines for that extrusion. Now I need reference lines for this back extrusion. Again, I'm not going to get crazy with all these little jig jogs. So let us go to create, reference line, arc. I'm just going to continue from here, ignore the jog there, and go up to here and just get close. There. And then from here, I'll go to the center and get close on that arc. And it kind of tries to snap you into a tangent like it did, so they're continuous. It's very helpful that way. And now I need to mirror, and I'm holding Control down to select this other piece. These two pieces I also want to mirror. Now I could have done all these before I mirrored, but it works either way. So now I'm mirrored there. So now I can even move this PDF out of the way, and you can see my reference lines. So now I have the lines I need to do my extrusions. And in 3D, you won't even see reference planes. So back to my reference level. Now to start an extrusion, let's go up to Create. You can see here we have extrusions, blends, revolve, sweeps, swept. There's a number of different tools to create all kinds of different shapes. This void forms will even let you put in hollows in the middle of your extrusions. But in this case, we just need a couple of extrusions. Now, one thing we need to know is how tall do we need this extrusion? What length? Well, back on our PDF, on this one, I had looked at some dimensions, and again, they're both about the same dimensions. The full height of the back wireway extrusion is 71 inches, and the height of the front extrusion is, I dimensioned it, it's roughly 4'8". So we're going to make this extrusion 4'8". That will approximate the size. So we're going to do an extrusion. Now, we're in sketch mode. You can kind of tell that because there's a check mark when you're done sketching. But we're in a sketch mode right now to sketch the boundaries of our extrusion. Now, this is where these construction reference lines come into play. We can use these to set up the boundary. So the way we do that is instead of drawing over them and retracing them, we can just use a tool up top here called Pick Lines. Creates a line based on an existing wall, line, or edge selected in the drawing. So we're going to do Pick Lines, and we are going to pick the reference lines that we already drew to be the boundary of the extrusion. And it has to form a complete path without overlaps. It has to, be exact. Now, if this was going to be an extrusion that we would dimension and possibly change the shape of, we would want to lock this extrusion to the construction lines, reference lines with this lock. We don't need to do that here. I will do it as a good practice. So if we were to move if we want to change the shape of this extrusion, we could change the shape of the reference line. So we will just do that. And then what is the depth or the height? This means the height. It's going to start at a reference plane and go up. What's the height? We've set it 4'8". 4'8". Enter. Now we've set up our extrusion in sketch mode. Once we click check mark, it will create the extrusion. Now it did that. So now if we go to our 3D view, zoom all, ZA, we can see our extrusion, and let's do kind of a front top view. So now you can see our extrusion that we did. And I kind of like to go with the realistic view. There it is. We just created that fairly simply. Just extruded that shape all the way up for 4'8". Now go back to our reference level. Now we need another extrusion for the back. So similarly, let us just go to Create, Extrusion. We're going to use Pick Lines to, again, pick the boundary of this extrusion using these reference lines. Lock it in. And this one, what height do we want this? Well, in our diagram here, it is 71 inches. So let's go back to 71 inches. We can type it in feet or inches, or just 71 inches. And it started at the reference level and went up. So let's see what that looks like. There we go. So now we have the two extrusions. Now I would like to add, just for some detail, the cord attachments that we see in this diagram, these little guys here. And I measured them already. They're about 5 or 6 inches tall. So we'll just make them 6 inches tall. And how wide are they? They're roughly 2.5 inches wide, 2 inches wide. And then how tall are they? Looks like they're about the same. Not tall, but what's that dimension? Roughly 2 inches. So they're about 2 1/4, 2.5, something like that. So we'll get close to that. So back to our reference level. Well, thinking ahead, we want these extrusions to start up in this region. We don't want them to be extruded from the ground or from the bottom reference plane. So let's do another reference plane to start our extrusion up in this area. So from this photo, we are going to be up about, and we can measure this if we want to get close to exact. We're going to be about 4 feet. So let's do a reference plane at 4 feet. Well, how do we do that? We can't do that from here. We need to do it from a front or side or back view. So let's go to front view. And let's create a reference plane this time. We want a plane. And you can use this to dimension it if you want, or you can always move it later. 4 feet, I usually extend these about the same as the others and make sure it's flat, level. And a good practice is to name these reference planes for future reference of chord. It's like documenting, coding or software. It's really helpful later. So we have that. And then we know we're going to stretch up about 5 or 6 inches. That's not super critical. We don't need to do a reference plane for that. Now, again, if we were going to create this family such that we could change these dimensions in our model, then we would get even more specific about more reference planes for every surface, bottom, top, sides, even radius, things like that. But in this family, we're not going to be changing those dimensions on the fly. This is going to be set. So we're fine with just minimal types of reference lines. So back to our reference level. We need to draw this cord connector. So we can draw some reference planes again to help us here. This is 1 something, so 2 inches. Let's just do 2 inches there. And we'll draw another one. We can just do create similar. We can click on that and then click on the dimension to set that. We're going to do 2 inches. And then from here out, we want this to be roughly 2 inches, maybe 2.5, I think. Two and a half inches. That's to the end of the arc. So the actual line, we're going to make it just 2 inches. Okay, so let's do our reference line again. Just lines. from here to there, from this intersection to this intersection. To this intersection. Now we want to create an arc. Endpoints here. And we want this to be, pop it like that. Now we have the construction lines, reference lines for that piece. Now, when we create an extrusion, we're going to be selecting all these pieces, but what happens here? If we select that, we have it selected the extrusion. If I use tab, then I can actually pick the actual reference line. Our reference line is too long, and it won't accept that for an extrusion. We need to be exactly this length. So we really need to draw another reference arc just here. So let me pick that point and that point, and then it will snap. So now we have, if we use tab, now we can find the line that works for our extrusion. And hit Control to get all of these. We're now going to mirror this whole piece over to this other side. Mirror, use that. There it is. Now we are ready for more extrusions. But we want to start at our 4 foot high dimension. Now we're ready to create the extrusions. We'll have to tell it where to start the extrusion because we want to start up at the bottom of these cord connectors. So when we go to create extrusion, we first need to set the work plane. We don't want it at the reference level. We want to start at the bottom of the cord attachment. This is setting the bottom of our extrusion at the bottom of the cord attachment. Say OK. Now we need to select the boundary of our extrusion. So remember, we use up here under draw, we use the pick lines. We're going to use existing lines. Hover over this, and that's the long line. So hit tab, and there's the shorter arc. Pick all of these arcs, lock it, lock the extrusion to the reference lines. So now we have the boundary of our extrusion. We only want to extrude it 6 inches above our reference plane, in this case, 6 inches. Enter. And go. So what did that do? View, there it is. Look from the other corner. There's our little cord extrusion. Okay, back to reference level. We're going to do the same thing on the other side. We're going to create one more extrusion. Go up to Create Extrusion. Set our work plane. It remembers bottom of cord, so we're good. Now let's use pick lines. Tab to get the short one. Work our way around. Lock it. Depth is still set to 6 inches, so we're good there. And let's hit go. Escape out, and here is our completed geometry. So now we have the geometry for our piece. We're not going to model the cords or connectors, or, you know, the receptacles and all of that, and the plugs. We're just going to do this. This gives us enough. So now we just want to add some electrical connections to this. We can get rid of this PDF now. So how do we add electrical connections to this thing? It's another create task. So under create, we have all these things we can create, and we want electrical connector. Now in this case, this is a dual circuit charging point. So we're going to need to add 2 electrical connectors. If you add both connectors at the same place, it's tricky to select them later. So what I like to do is add them to two different planes. So I go add electrical connector, pick a work plane. Now I can pick it by this, or I can actually pick on the 3D. I'll just pick it here. So let's pick the reference plane, the reference level. For the first connector, we're going to put it at the reference level. Say OK. And that is the symbol for an electrical connection. Now what's in this electrical connection? Click on it and take a look. It has system type, unbalanced or balanced. Now, it's very critical that we go with balanced, because if we put a load on this, into this system, into this device, we want it to be spread amongst all the phases. Now, if you only have a single phase line to neutral load, that won't matter. But if you get a 2-pole and 3-pole type of load, it will matter. So go balanced. And that way we just have one apparent load that gets spread amongst all of the poles. Number of poles, now, this can all be changed later, but I at least like to set it up for what's most likely going to happen. Lagging is fine. Voltage, we're going to set this one up for 208. Apparent load, well, 32 amps at 208 is around 6,600. Power factor 1 is fine. So we've got this set up for connector element 1. Apply that. Now we need another connector. So we go to create electrical connection, work plane. I don't want to put it on the same work plane because then I can't pick it later. So I'm going to use let's just use the bottom of cord attachment. That way it is visually separate and I can pick these individually. So this one, let's do the same thing. Balanced, 2-pole, 208, 6,600 watts or VA. Apply it. So that sets up the electrical connectors. Now the only issue with those is these connectors are buried in this family. It's kind of like they're nested into this family. So if I was to bring this family in right now into my electrical model, I can't get to those connectors. I can't change them. They're nested in the family and I can't get to them. The way that I can actually get to these is to create type parameters in my family that these electrical connectors get mapped onto. So it brings those connector parameters up a level to my family so I can get to those. So what I need to do now is up at the top left, family types. I need to add the information here that you will see in the actual model. You'll see it as a type parameters. You know, when you hit edit type, you will see all these listings. We need to add these parameters. So we're going to make up some parameters that we can map the electrical connector parameters to. And we have two sets of electrical parameters, as you recall, because we have two sets of electrical connections. So let's start with the connector number 1. We are down here going to do a new parameter. These are just family parameters. We're going to call it load classification number 1 for connector 1. The discipline is electrical. What type of parameter? Well, it's a load classification. So we need to go through all of these available electrical parameters and map it to, at the bottom, load classification. And then group parameter, it's going to group the parameter under which heading. So when you look at the type, it'll be under different headings. It can be geometry. It can be, all kinds of headings, mechanical. We're going to call it electrical. You can either use electrical or electrical loads. I like electrical loads. Okay, so now it's under electrical loads. And we're not going to assign a value to this yet. We're just creating the headings. So now we need to do this for the other parameters we need. Now we need a number of poles, but for connector 1, electrical. This is called number of poles. This is a built-in electrical parameter we can use. Type. And then we want it to list under electrical loads with the other one. So now we have load classification and poles. Let's do voltage. Voltage. Repetitious here. This is called, they don't call it voltage, they call it electrical potential. And this will be under loads. And then finally we need an actual load, the apparent load in VA. So let's call this load number 1. Discipline, electrical. Apparent load, apparent power. And it goes under electrical loads because it knows it's a load. So there, we can we'll rearrange these, the order that we like for these later. Now we need to do this for number 2. Load classification. Number 2. Electrical load classification loads. Poles. Number 2. Electrical. Number of poles. And loads. Let's go to voltage. Let's go through all the repetition here. The electrical potential, electrical loads, and finally, the actual load, number 2, electrical, apparent power, loads. Okay, now we have all of our parameters. We can move these up and down with the tools at the bottom. I like load classification. I'm going to group these as number 1. We're going to go to poles number 1. Next. Voltage number 1, third. And load number 1. And then load class number 2. Poles number 2. You can order these however you like. Voltage and load. Okay. Now we have all of our type parameters described, but now we need to map, associate each electrical connector parameter with the type parameter of the matching name. So the way we do that is click on, this is number 1 down here, and we can't name these. These are just an electrical connector, so it's helpful that we map them. So what we do is we're not going to be able to change the system type later on in the family. We're going to leave that as balanced. Number of poles, we want to map that. So on the far right is a little button called Associate Family Parameter. We're going to associate this parameter with the family's parameter. So click on that, and here we go. Our choices for number of poles is poles 1 and 2. We're doing number 1 right now. So pick poles 1. Now this connector's pole is mapped, and it grays out, is mapped to the family's parameter. Load classification. We want that number 1. Now it's telling us that I have to actually fill out this load classification first. It doesn't like it empty. So let's get that done first. Now it should let me apply it. EV charger, okay. There. Now it'll let me map it. Voltage number 1, and apparent load, map it to apparent load load number 1. So there, now we're all mapped. And if we go back to this, you don't see it here, but you can tell from here they gray out, which means they're mapped. They are controlled now by the family's types parameters, not by the actual electrical connection itself. So now let's click on the other electrical connection. Balance number of poles, and this one got changed to 3. Let's go poles number 2. Load classification, EV charger, map it to load class 2. Voltage, map it to voltage number 2. Apparent load, map it to load number 2. And now those are mapped. So we're done. This family is ready to be inserted into our model. Now we can insert it and test it, make sure it works. I did a video already where I insert this in and connect up the 2 connectors independently. So that is how we developed a 2-circuit EV charging point. Hopefully this is helpful for you. And until next time, thanks for watching.